Hello, everyone. This is Professor Su. I like to take the opportunity to review this C programming language course from inception to end. This review is going to cover a couple of topics we already went through, with emphasis on some of the more important ones and some of the gaps we might have missed. Without further ado, let's get started. Let's look at this simple structure of a C program as a start. When we first introduce C, on the top of the screen here, we have what's called multi-line commenting. This is formed by way of / start, and then you have the reverse of it. So you can write multi-lines. If you want, you can also do individual lines using 2 /. The next line is what we called import directive. This effectively imports libraries, standard libraries, that includes input and outputs. This is a header file that sits in your native computing environment with C installed. And typically this is part of your Linux, but you have to use it if you want to print or ascertain user inputs. Again, we're going to see a whole bunch of lines with what's called macro. This is another way of defining constant. So when you have a pound define, remember this is preprocessor definitions. Your precompiler or your preprocessor, which is a software in C, looks at these things as part of the compiling business logic to interpret every time when this particular keyword exists, it translates to a value of 0. Upper limit having a value of 12, etc. So it's this one, preprocessor definitions. Let's look at some of the functions. This is what's called forward declarations, where you declare a function, essentially its signature with the function name, the return type, as well as the parameters list. In this case, 2 integers. Let's move on to the next slide. We're getting into the main, or the entry point for your console applications. Every time you see main, this is a signature for a console. So console is that black box or the windows. On Mac, it's called terminal. On Windows, called CMD. So they are different names, but the console application allows you to print stuff to that screen. So this console application has an entry point called main, and main is a default entry point function. So this is a function with a pair of curly braces. This is the functional scope within which you will see the business logic, starting with declaration of a variable n. This is of integer type, and you're printing this out to your screen. \end represent cache return. So as soon as this is printed with printf, which is a function of your std io.h, the standard library, you will get a cache return in this terminal space. But if you don't have this \n, what you end up with is just a whole bunch of concatenated one-liner, one string, all the way from left to right across the entire screen. Let's move on to the next one. This is a for loop starting with n that you declare. We know lower limit as a macro. We know upper limit as a macro. Typically, as a standard practices, you will want to use upper casing for these macros. This example is not that good. It uses a camel casing, which is not very conventional. So as a best practice, you will want to write upper limit as UPP, all uppercase, ERLIMIT. That's more of a convention. So you would not confuse with ordinary variable naming conventions like this. So the for loop has 3 sections. One is an initialization, one for conditional check, and another one for increment or decrement. So this means that the end will iterate, or this entire loop will iterate from n equals lower limit. This will be the first loop, up to upper limit minus lower limit plus 1, because there is the less than or equal to. So that's the number of iterations you have. So if lower limit is, let's say 1, upper limit is 10, there's actually 10 iterations here, because we're doing n less than or equal to 10. Okay, so if you do the math, there's 10 of them. This simply prints certain things. As you know, these are wildcards that represent the 2 digits, 3 digits, and 4. So there's actually a lot of these formatting things that you can refer to inside of printf. There's actually an example of this in assignment we did. You also have raised in power. This is the function that we just wrote or declared, but we haven't seen the definition of these functions yet. So let's take a look. This raised integer powered function takes two integer parameters. And then further up, we have internal business logic calling for the exponential business logic for raising this n to the kth times. And this result is the manifestation of this for loop that goes from I equals 0. Alternatively, you can use integer I here, then you don't have to declare. The reason why you would want to declare upfront to make them global in the context of this entire function is if you want to leverage I for something else later. But since I is not really being used, and the for loop is the only one that is using it, there's no need to declare this upfront. Initialization portion of your for loop is only used once. You don't come back to it many times. So it's not that if this loop iterates 100 times that your integer will be declared 100 times. No, that's not the case. This is what's called initialization. So it's safe to have this seen here, even with the declared integer, and you don't have to have this. Result, on the other hand, it's okay because you want to carry the entire result or the single result all the way from the beginning when it is initialized to 1 all the way to the default return. There's no need to have the parentheses over here, but having it also doesn't hurt. All right, let's move on to the next slide. Let's introduce a couple of variables and values and types. A variable is simply just a label in memory. If you think of this entire memory as this cloud right here, your label might be referring to this piece. And this piece should have a memory address associated with it. And usually that's expressed in hexadecimal numbers. Let's say 0 times FA2. And this number could be expressed as an integer. So this is integer in hexadecimal format. A variable occupies a memory space when declared. And this is the reason why you would want to put the type of variable, like integer I, for example. And I, in this case, will be the variable name. And that's simply the identifier. And this identifier could be anything. It could be X, Y, and Z, it doesn't matter. At decoration, it would have a memory space associated with this. Because this decoration doesn't involve heap by way of malloc, this is dynamic memory allocations. In the absence of any heap new malloc, this memory space is what's referred to as stack memory. So you're allocating space on the stack. So we talked about variable, we talked about identifier. Let's also talk about a couple of rules associated with this. The identifier or the name itself cannot be just anything. For example, you cannot write integer pound. You cannot write integer question mark. They're not part of the same rules. So follow these rules. They could be a sequence of characters, alphanumeric digits, or special characters to some extent, such as underscore, but not anything else. If you have a letter or underscore, they must be the first character of an identifier. For example, underscore XYZ. This is a valid identifier. C is also case sensitive, so apple and small apples are two different things. This is very important to understand. Let's move on.